Let me ask you a question. How will you find tomato in a grocery store? You will look for a vegetable which is red in color, oval in shape, juicy, and weighs around 40 grams. Red is data, vegetable is data, oval is data, juicy is data, and 40 is data. Simply put, any information is data. Any fact or number is data. We usually collect them so that we can analyze them using logic to understand the word better or make decision. We cannot buy tomato if we cannot describe them in the first place. Without data, there is no computer science. And as the name implies, neither data science nor AI. Data is lifeblood of AI. Hello, welcome to Myra. In this article, we are going to explore what data is and its different types. So let's begin. To brush your teeth, you pick up your toothbrush, not other types of brush. In the same way, data type is derived from the operation we wish to perform. If we wish to perform addition, subtraction, multiplication or division, we need data types which are numbers. Numbers come in two varieties, integers or floats. Operations like 2 plus 4, 2 minus 4, 2.4 plus 4.0 needs number data type. Consider this text. Now as we can see, there are lots of uppercase and lowercase mismatch in the above sentence. In order to process this, we need a data type called strings. So the whole sentence is a string. After running the formatting operation, we get this. Data types can only be defined based on context or operations. Hey, will you come to the cinema with me? Or say Aditya Khandala. For questions such as these, the typical output we expect is yes or no. In order to record such true or false outputs, we need Boolean data types. If the answer is yes, the value is 1, or when the answer is no, the value is 0. The three basic data types are number, strings, and Boolean. When thinking about data, it is important to keep in mind that data describes the information or defines the value. They define operations which are allowed on these values. Now, let us explore ADTs, that is, abstract data types. When we wish to watch a TV, we simply pick up the remote and push the on button on it, followed by channel numbers and start enjoying. We do not care about the inner working of the TV or remote. We are only interested in the high-level working of the TV. At times, analyzing certain things from a distance helps us understand core concepts without getting into nitty-gritty. This is abstraction. In computer science, in order to make things simple for a programmer, we abstract things. A programmer can simply write his code in human understandable language without worrying about machine language in which the processor finally executes it. We will be discussing few entities, which are stack, queue, lists, maps or dictionaries, and sets. So let's start with stacks. Consider the above deck of cards A, K, Q, J and 10. In order to arrange the card like this, you will first need to put A on the table followed by K and so on. Now consider which operation can be performed on the stack of cards. We can pick up 10 from the stack, but we cannot remove J without removing K from the stack. The card which comes before, in this case A, cannot be accessed without accessing all the cards which comes after A. It's kind of first in last out. Secondly, we can put another card 9 on top of 10. When we have data which is arranged linearly with operations defined as push, pop, We call it stakes. Without going into detail on how the values are stored in the memory, etc., we simply say stakes are kind of abstract data type that we can use in our applications. Now, queue. Consider the above queue at a ticket counter. Let's say we have the following operations which are allowed. The first person in the queue will be served first and any joining has to be added towards the end of the queue. It's the first in first out. When we need data to be processed in such a manner, we need the abstract data type called queue. Queue is also a linear list on which we can perform the following operations. Queue, add an item to the back of the queue. Dequeue, remove the item at the front of queue. Now consider the queue of patients at a hospital. Some of them are serious while some are there for a regular checkup. In that case, we can define a particular patient with two numbers, position in the queue and severity. For example, patient at position 5 with a severity of 8, assuming we index severity on a scale of 1 to 10 in an increasing order. So our patient will be 5-8. In the light of this new information, we can change the rule of queue processing. We can say the hospital needs to attend the severe patients first despite their position on the queue. What we did is we basically assign a priority information to the queue and change the operation rule. This kind of queue is called a priority queue. In such case, an queued item must have a priority assigned to them, and instead of enqueue, this type of data has EP operations where P is the priority assigned to the item E. Consider the basket. It has apples, oranges, onion, grapes, capsicum and other veggies. You can simply make the list of veggies in the basket as apples, oranges, onion, grapes, capsicum and so on. Now imagine we can at wish pick up any fruit or veggie and eat it, or we can add more veggies in the basket if needed. If we are allowed to do such operations, then the data type is called list. We can store any primitive data type in a list simultaneously. Unlike stake and queue, this gives us the freedom to access, add and replace an item from the middle. We can perform the following operations on list: insert, remove, get, sort and reverse. Maps. Recall your school days. You were assigned a roll number and while taking attendance, teachers used to call the roll number. Each of your classmates has unique roll number assigned to them. Similarly, in the case of data, we have a data type which does that. It is called map, dictionary or associated array. Map is used to store the mapping between two objects, that is the key object and the object value. For example, they can be used to store a user ID as number and key as username as value. We can perform the following operations on map: set, delete and get. Sets. A set allows you to store unique non-repeated values. They are like mathematical sets. When the order of the data is not important, you can use a set. For example, a set of prime number or set of animal or set of integers. Supported operations on set are add, delete and list. So this was all about entities. In this video, we got to know what are data types and different types of entities. Thank you for watching the video. Please like the video and subscribe to the channel.